Hello everyone, in this video I'm going to show you how to compute Spearman correlation by hand. Okay, let's say that you have a group of data on married couples on their taste preference for vegetables. So this person who was having a market or a grocery store was interested to see if husband and wife has same preference or same interest on the vegetables. So what he did was he listed 7 types of variables. So he gave broccoli, cauliflower, sprouts, okra, cabbage, spinach and turnips. So these are 7 different vegetables, and independently he asked the husband to list out his most favorite vegetable to the least favorite. Okay, and the same thing goes with the wife. So he asked separately. Okay, they were separated, the husband and wife, and the wives are also given the same list of vegetables, and they were asked to rank it or order it from the most preferred to the least preferred of the vegetables. So basically husband said broccoli is his 4th choice, for wife it is a 3rd choice. So for husband the first choice is okra vegetable, and for the wife the first choice is cauliflower. So this grocery store owner is interested to see if there is any relationship between the husband and wife on the preference of the vegetables. Okay, so that's what has been explained here. Okay, so they rate their preference for 7 vegetables from most preferred to the least preferred. So let's see, how did they actually find the Spearman correlation. So Spearman correlation R in the subscript of S. S represent Spearman. So these are the vegetables. These are the husband's responses, the most preferred to the least preferred. This is the wife's responses from the most preferred to the least preferred. So what is the step 1? Find the difference in rating between husband and wife. So what we do here is the husbands and the wife. We take the difference between the 2 responses. Okay, so it can be husband score minus wife's preference or wife minus husband. Okay, it will still give you the same values because later on we are going to square it, so it doesn't matter. So take the difference. So the difference is this column value minus this column's value. So husband's value minus wife. 4 minus 3 equivalent to 1. Then 3 minus 1, 2, followed by 6 minus 7, negative 1, and then up to the last one. So that is the first step. Second step is square the difference and add all the squared differences. So here is the difference, right? So these different scores are squared. So 1 squared, 2 squared, negative 1 squared becomes 1. Negative 1 squared becomes 1. So when you do all for all the 7 options, 7 vegetables, and then you add them all up. So you will get 12. How do you get 12? 1 plus 4 plus 1 plus 1 plus 0 plus 4 plus 1. So that is how you get the sum of D squared. So the third step is use the information from step 1 and step 2 into the formula. So what is the formula for Spearman? 1 minus 6 times the sum of D squared divided by n squared minus 1. So the n is the number of pairs that you have or number of vegetables that is being ranked. You have how many? 7. So n will be 7. So when you compute the information from 1 and 2 into the formula, becomes 1 minus 6 times sum of D squared 12, 7 number of cases multiplied by 7 squared 49 minus 1. So when you solve this and subtract it, you get 0.86. Round it up to 0.79. So that is your Spearman correlation coefficient R. So that is just your R value. So what do you need to know? Does this R has a significant relationship or not? Is it really significant? Okay, so what do we need to do with that? You need to do a hypothesis testing. Because remember, whenever we are running an inferential analysis, we are actually testing for hypothesis, the null hypothesis. So what will be the hypothesis in this case? There is no relationship. So how do we represent that? How do we determine that? So what we do is, we convert the R into T. So the T here is R, the Spearman correlation coefficient that we found, divided by the square root of 1 minus R squared divided by n minus 2. And the degrees of freedom is n minus 2. So the for R Spearman is 0.79. When you square it, you get 0.62, n equals to 7. Degrees of freedom is 7. You have 7 observation, minus 2, you get 5. So with use this information, you can get your T statistics, which is 2.88. Then what do we need to do next? We have to compare it with T critical. So to find the T critical, you need to have 3 information. Firstly is the alpha value or the significance level. You need to know tails, whether to use 1 tail or 2 tails, and then your degrees of freedom. Here our hypothesis is there is no relationship. So when there is no relation, there is no direction, so we use 2 tail. If in case we say that there is a positive significant relationship, then the tail will be 1. Because there is a direction in your hypothesis. So to determine the tail, you have to go back to your hypothesis. So where do you get this information? Using this information, you go to the T table and you find the T critical. So the T critical is 2.571 for alpha 0.05, 2 tail for degrees of freedom of 5. So once you get your T critical value, what do? We compare it with our T statistics. Okay, so basically a person, you have to get values greater than this cutoff in order to say there is a significant relationship. So here we compare it. So 2.8 is our T statistics and 2.571 is the T critical. So since T stat is greater than T critical, we reject the null. So when you reject the null, meaning there is a strong positive relationship between husband and wife, preference for vegetables. When you say there is a relationship, what does that mean? Meaning wife and husband has different preferences for vegetable. What we are trying to identify just now is, does this couple has any relationship with their preference? It shows yes, there is a difference in the preference. Husband and the wife has different choice of preference in terms of vegetables. So that is how we answer this question. Hope it was clear. Thank you.